I want to find voltage drop V0 across the 1 kilo ohms resistance, and I will use Norton's equivalent circuit in order to do that. So what I will do, I will first disconnect this 1 kilo ohms from the circuit, from the original circuit, and replace it with a short circuit to find Norton's current first, and then I will find Norton's resistance. Maybe I will do the Norton resistance in the next video because I don't want to make the video too long. So in this one I will just find the Norton's current, which is I short circuit current is I Norton. So this is 10 kilo ohms, 3 milliamps, 2 kilo ohms, 24 kilo ohms, and 12 kilo ohms, 36 volts. So there are only two independent sources, one voltage source, one current source, no dependent sources. So first what I will do here, I will convert this voltage source and series resistance into a current source and a parallel resistance. So the polarity, the direction of the current will be like that because voltage polarity was in this direction. And then I will have, so this is 12 kilo ohms, this is 24 kilo ohms, nothing from here, from this side, this part only is changing, and here it's 3 milliamps, and then so everything else remaining the same. So this one here is 2 kilo ohms, that resistance, and value of the current source will be 36 over 12, so that will be 3 milliamps. So now I can find an equivalent resistance of these two are coming in parallel, 12 kilo ohms, 24 kilo ohms. So the equivalent will be 24 times 12 over 24 plus 12, which is 36. So that will be 8. So I will have 8 ohms, 8 kilo ohms there, and 3 milliamps as it was, and then this is 2 kilo ohms, 3 milliamps, and then 10 kilo ohms. So like that, this is my desired current. So now again I will reconvert it into a voltage source and a series resistance. So it will be 8 kilo ohms, 2 kilo ohms. It's just repetitive drawing, but this one, and then this is 10 kilo ohms, and like that. So the value of the voltage source will be 3 times 8 volt, so that's 24 volts. And this one I can write just with one resistance, 10 kilo ohms, and then this one. So basically I still have one voltage source and one current source here. So there are several ways to solve this. 3 milliamps, this is 10 kilo ohms. So there are several ways to solve this one. What I will do, I will write KCL at this node. So let's assume the voltage of this node is V1. So I will write KCL. So V1 minus 24 over 10 is the current that's going in this direction. Then the downwards current is 3 milliamps. So I'm just writing all the outgoing currents plus V1 over 10 is equal to 0. So sum of three outgoing currents. So that's V1 minus 24 plus 30. So I'm multiplying both sides by 10, and then V1 is equal to 0. So 2V1 will be minus 6. So V1 will be minus 3 volts. So I short circuit will be, of course, V1 over 10, because this is the current which is I short circuit, which is I Norton. So that will be the voltage here divided by the current, the same current that's going in this direction. So that will be 3 over 10 minus 0.3 milliamps. So that's the value of Norton's current. It means that the direction of the current source will be in downwards, so like that. And then I will have to find Norton's resistance, which actually I can do now quickly. So if I go back to the original circuit, I can do from there. or maybe I will just do from uh, any point, maybe this one, because it's the same circuit. So when I remove this part, I'm just erasing, and I will see what is the value of the resistance as seen from here with the sources making all the sources inactive. So for this circuit it will become like this. So voltage source short circuited and current source open circuited. So that's there, so and that's there. So 10 kilo ohms there, 10 kilo ohms there, and this is the resistance I am seeing. So basically R Norton will be 20 kilo ohms. I would get the same result if I had done from the original circuit, which is the given one here. That would be the same, because I just had to find the equivalent resistance, and this one being short circuited, 12 and 24 would come in parallel. That would give me 8 kilo ohms, and then 8 plus 2 would become 10, so it's just the 10, and this one would be open circuited anyway. So my Norton circuit, I am finishing off it in this video, will be downwards. 3 milliamps will be the current, and resistance is 20 kilo ohms, and the resistance across which we want to find the drop which we disconnected is 1 kilo ohms, and the voltage drop across it is V naught. So that's what I want to find, and the value of that now will be, of course, V naught will be the current I, which will be in this direction, that will be negative because it's in the other direction, times, of course, just 1 kilo ohms. So current will be in milliamps, and the value of the current will be, of course, 0.3, that negative sign is there, 20 plus 1 times 20. So that will be, I'm not doing it, I'm leaving it like that. So that will be, of course, so it will be 6 over 21, which is 0.29 approximately volts. So that will be the value of the voltage drop.